Most people believe that when a jet engine fails, it erupts into a massive ball of fire and tearing metal. To uncover the terrifying silence of aviation engineering and understand the real threats in the sky, hit the subscribe button and join our deep dive. But the absolute truth is that the most catastrophic engine failure is completely invisible and completely silent. Welcome to the reality of the compressor stall, a phenomenon where the heart of the engine literally stops breathing. A modern turbofan is not just a tube of fire, it is an incredibly precise air compression machine. At the front, massive titanium blades pull in tons of air every single second. This air is forced into smaller and smaller spaces, raising the pressure to extreme levels before it ever meets a drop of fuel. The entire system relies on a delicate balance of aerodynamics. If the angle of the incoming air changes by just a fraction of a degree, the airflow over the blades can detach. This is exactly what happens when an airplane flies through turbulent air or ingests a foreign object. The high-pressure air in the back of the engine suddenly rushes forward out the front. The engine chokes, the fire in the combustion chamber is instantly blown out, and the massive machine simply goes dark. But the most shocking truth is not this. The secret I will reveal at the end of the video will make you forget everything you know. Inside the cockpit, the pilots do not hear an explosion. They watch the engine RPM gauges quietly drop to zero. The terrifying reality is that a jet engine is designed to shut itself down to prevent internal destruction. If the internal temperatures exceed the melting point of the metal, the turbine would literally liquidate. So the computer cuts the fuel line in a fraction of a millisecond, leaving the aircraft as an incredibly heavy glider. Restarting a dead engine at 30,000 feet is not as simple as turning a key. The pilots must dive the aircraft to force dense air back through the frozen blades. This is called a windmill start, relying entirely on the speed of the falling plane. If the compressor blades have been damaged by the initial stall, the engine will never restart. Engineers spend billions of dollars testing these engines against extreme conditions. They fire massive blocks of ice into the spinning fan to ensure it can survive a frozen storm. Yet despite all this titanium and carbon fiber armor, the engine remains fundamentally vulnerable to the very air it breathes. Volcanic ash is another invisible killer that causes the silent death. The microscopic glass particles melt inside the combustion chamber, coating the internal sensors and literally suffocating the engine from the inside out. No fire alarms trigger, no smoke fills the cabin. The passengers remain completely unaware that the giant thrusters outside their window have died. This is why the architecture of the engine focuses heavily on stall recovery systems. Variable stator vanes automatically adjust their angle to keep the air flowing smoothly. Bleed valves open instantly to relieve explosive pressure buildup before it destroys the core. Aviation is an endless war against the laws of physics, and the jet engine is our most magnificent weapon in that war. But nature always finds a way to exploit a mechanical weakness. The next time you look out the window at that massive metal cylinder, remember that its greatest enemy is not fire or heat. It is the sudden absence of airflow. Now you know the truth about the silent death. But what happens when the computer system that controls these engines decides to lie to the pilots?